All right, now picking up where we just left off. The DE stop allows us to be able to control how close the ray, each of the rays, comes to the object to allow us to optimize the quality of our image and also optimize the rendering, the amount of time it takes to render the whole scene. Keep in mind, each one of these rays, you know, there's millions of rays being shot out for one view of the image. Millions. Each of those pixels had to have a ray that was emitted from a simulated camera, okay, until it built the image. The problem is that the rays are not always 100% accurate, and you can fudge with the DE stop how that ray behaves. Now, we're artists, so let's focus on the result, not so much the tech. Now, I had a DE stop of .1. Now, I want you to kind of watch how long it takes to render this. I'm going to hit calculate. You're looking down here. This is a one formula Mandelbulb object. Can you imagine if you had 6 formulas here? The render time takes time. Let me punch it again. Down here, that's the rendering. And then the next progress bar was the shadowing. Matter of fact, I could even, nah. I was going to turn the shadowing off, but I don't think I will because it's not realistic. Okay. All right, so a 0.1. The rendering is going to take longer than if I have, say, a DE stop of 8. Watch down below here. Calculate. Is how much faster that is? But look at this. You see the effect that it had? My DE stop now is way back here compared to what I had before. All right, now let's see if we can understand the end result of this DE stop. Now, let me do this. I am going to set this fractal to 3840, which is 4K. I'm going to calculate it because I want to get in on a certain point. There we go. There we go. Now, what we want to focus on here is all of this stuff in here. I'm going to DE stop of 8 now. You see all these little white dots in here? All right, and you see all this scratchy stuff here? All right, now let's take a screenshot of this. All right. Oh, I'm going to pull in the 8, the DE stop 8 as well so that we can keep track of that. All right. Well, by the way, I don't need this Stream Deck showing up on your screen. I'm going to get rid of that for you. All right, so this is a DE stop of 8. Now I'm going to do a DE stop of 1, calculate it. You see how much longer that took to calculate? This is a 4K image now. Now let's look at the result. Not only do I have more detail up in this area, all right, look at that, I got much more detail, but I actually have, if you just focus on this part right here, all right, I actually have, it's better rendered. It's better rendered. So with a lower DE stop, a 1 compared to an 8, I am getting much better quality. I'm getting more detail. But that's not the end of the story. Now, let's do this. Let's come over here And let's do a capture of that. I'm going to capture that DE value as well. Park that aside. Now let's put a DE stop of 0.5 in here. Calculate. You see it's taken even longer to render. Longer to render because we're asking the software to be more precise on where that ray intersects with the object. Not all rays intersect with objects. Some rays miss objects entirely, and they go off to infinity. That takes time. Now let's compare. This is the DE stop of 0.5, and this is 1. All right. Now I'm getting to a point here, if you just kind of look at this section right here, it's not a whole lot of improvement, is there? Not a whole lot. All right. But now, you see these white dots everywhere? Let's see. There's a whole bunch of them in here, but there's a white dot, a couple of white dots right there. There's one right here. That's a good one to pick on. Now that white dot is probably oversampling. In other words, the ray came up on the object and doesn't really fully understand where that ray intersected with that object. And so that ray calculation effectively fails. It fails. All right. With my DE stop of 1 over here, I told it, look, when you get to about 1 pixel, just stop, figure that's where you want to be. But with a DE stop of 0.5, all right, here we go. Let's get this way over here. All right. Here we go. I got a white dot right here, and that white dot is gone. Okay. All right, I had, let's see, I had white dots up here, which would put us right about, let's see, right about here. I still got a couple white dots in there. All right. So with the DE stop of 0.5, I have longer rendering, but I have less oversampling of rays. I have less white dots. Let's take this a little bit further. Let's capture this with my 0.5 DE. Wink. All right, let's put a 0.1 in there. Why not? Calculate it. That's still rendering. Now the shadows. All right, let's see what we got here. This is my 0.5. I had a couple white dots in here. Oversampling is technically what it's called. I like to call it white dots. Okay, right in there. All right. So it seems to me that with the DE stop of 0.5 and no other values modified, but they also will have an impact on the quality of your rendering, but that's for later. We're only focused on DE stop at the moment. If I look at these two images side by side, this is my DE stop of 0.1. This is my DE stop of 0.5. What's happened here is that I have increased the rendering time, but I haven't really significantly increased the quality of my image. Not really. I have more rendering, but not really a whole lot of improvement on the quality of the fractal. And I am 4K, and I'm looking at a small part of it because I used my main window to focus in on this whole thing. All right. So let's get back to, okay. So if you look at those two side by side, I have more rendering with the lower DE stop, and not really a whole lot of improvement. As a matter of fact, I've actually gone backwards in quality, which I'll show you in the next session. I'll see you there.